with what we say as why sampling is important and how sampling is going to help us. I hope you can see my screen that tells about population structure, isn't it? Can you all see my screen?
Yes, we can.
Now, population structure, you know, either it is an ICT research or a social science research, the population may be different, but the scientific research process is same. So now you know a clear distinction: what is a homogeneous, what is a heterogeneous, what is a distributed, what is hidden, dynamic, and digitally connected population. So you don't find the digitally connected population in the old books of research, but it has recently evolved out because previously we don't have so much digital connected population. Now, just to make you understand what is real homogeneous and heterogeneous population, this is more important because if you know your population very well, it will help you to understand the choose the right sampling technique. That's what Veronica was saying. So, what is a homogeneous population? In a homogeneous population, as you see in the picture, the population, the members are very similar characteristics, like students in a single class, in one class. So, if you have that one, the good one is random sampling because every member has equal chance of being selected. But remind you one thing: if you want to use random sampling, you should have a population frame with you. Means what? You should know the details of each and every individual in the population or every entity in the population under study. So homogeneous, you can use random, but you should have a population frame. All the members under study are known to you. You should be able to draw out a list of the people. Then it is called as what? Um, a population frame. Now, if the people under study is heterogeneous, means what? The population members differ significantly. As I told in my previous session, it can be department, gender, background, nationality, expertise. So with many things, they may be different. So in that case, the best suitable sampling technique is stratified sampling. If you take a university, you have 5 faculties: Faculty of Engineering, Faculty of Business and Commerce, Faculty of Graduate Studies and Research, Faculty of Information and Communication Technology, Faculty of Health Science. So you can divide the population into different strata. Hope you're getting me. This is the technique what we use when we are using a university side wide study. So I know you get the clear distinction: what is a homogeneous population and what is a heterogeneous population. If population is heterogeneous, stratified sampling can be used. In stratified also, you can have different sampling techniques involved. So this is what is homogeneous and what is heterogeneous. So the key takeaway from this board is the nature of your population determines the most appropriate sampling technique. And if you have the most appropriate sampling technique, 100% your research, the quality of results will be good. So better sampling gives you better data gives you better decisions, leads to better research and better impact in the society. So this is all about homogeneous and heterogeneous population. Now, wait, my slides. Now, what is a probability sampling? A probability sampling, every member of the population has a known chance of being a sample. That's every member. So what does it mean? This reflects the miniature of the real population. When every member has an opportunity to become part of the sample under study, then that is real the miniature of the population under study. So the major types of probabilistic samplings are simple random. The second one is stratified. The third one is systematic, and the fourth one is cluster. So this we have discussed. I think this is the sixth time I'm discussing what is simple random sampling in my sampling techniques research lecture. Every member has a equal chance of being selected. This is simple random sampling. Very simple. What is stratified? We divide the population into strata. It is not of your choice. There is a reason. If you are doing a study in the university, you can divide them based on the faculty under study each student belongs to. If you are doing a study among the farmers, you can stratify them based on the type of farms they do. You can have coffee farmers, you can have tomato farmers, you can have sugarcane farmers, you can have millet farmers. So that's you, the researcher. You decide how you are going to stratify your population under study to choose the sample. So here in a university-based study, what we'll do, we stratify the population under study, the students under different faculty of studies. Now, in yesterday's class, when we are working with the field robot for agriculture, we explained very clearly what is systematic sampling. First of all, if you want to do systematic sampling, the population frame should be available for you. Otherwise, if you are taking a live data, what is a real-time data? You are waiting in front, you are going to take some data with the approval of each customer and the concerned people of a large store. So like you are in front of a store at the point of sales and you can fix every 10th customer. That is one method. But we don't know actually who all are going to come. So here the sampling frame is not known for us, but we know there are customers coming. Every 10th customer from the time period of 9 a.m. to 6 p.m. on weekdays. So this all comes as systematic sampling. But really when we do systematic sampling, what we do, every case member, this is what I discussed in the morning. You can fix k is equal to 10 here, or you can fix k is equal to 3. This depends upon the number of the population you are going to attend and the number of sample you are going to extract. Now, the other one is called as cluster sampling. Now, in cluster sampling, the population is clustered into different groups. And from that, we can select randomly. See, if you have a big school, and you may ask me now, what is the difference between stratified and cluster sampling? Now, I'll say we cluster normally organization, that is good for us, or we can cluster when they are geographically separated. So there is some confusion that happens between stratified sampling and cluster sampling to some researchers, but kindly go through what is cluster sampling, what is stratified sampling. So once it is geographically more separated, then it comes more into cluster. But depends upon the wideness of your research. If you are doing intercontinental research, maybe each continent can be either made as a strata or as a cluster, or the regions in each continent can be made as a strata, like East Africa strata, West Africa strata, if you're looking at African continent. So that is cluster, you can say the people in Uganda, or like that farmers, coffee farmers in Uganda. So when you're doing a global study. So that's, you should have a clear distinction, a clear identification what is stratified and cluster sampling. So the strength of probabilistic sampling, they are the most good ones, the most effective ones for scientific research. In almost all PhD researchers, we expect a probabilistic sampling. The goodness, it has a high representativeness of each member of the population to be a part of the sample. That means there is a high generalization capability. So the results can be more generalized. But it has a limitation because we need a quality good data population. Because we know that it works on the principle that every sample or the sample size, your sample frame should be a miniature of your population frame. So you should have a good knowledge about the kind of study what you're doing and what kind of people you have to, real life people you have to attend. So this is more important and this we call as probabilistic sampling. Now, what is a non-probability sampling? First of all, you understand which case we use non-probability sampling. We use it in exploratory or we use it in qualitative study. So the non-probability sampling techniques are more used in exploratory, qualitative study, or maybe case study. So basically, non-probability sampling, just reverse of probabilistic sample here, we cannot guarantee that every member of the population or every sample, as every member of the population has a chance of being selected as a sample. No. So here, one method is called as convenience sampling. The participants are selected because they are easily available. I just recall my days in Herefordshire, a county in England. So when we go to the city center, you can find a number of people who come with pen, paper, and some question takes. So they interview us. They ask us questions. They first ask, are you interested to join for a survey? It can be a market research. So here what they are doing, they are not coming our home, but they are doing a convenience. They come to the city center where we are having sitting, talking, having coffee and things. And they try to make a kind of facial connection. They look at you. If you smile, they will come to you and they ask, could you please help us with a kind of survey? But before that, they will make sure that I'm eligible to do the survey because they make sure that their survey has some purpose and does me comes under that category. They never force me. So this is called as convenient sampling because the participants are selected because they are easily accessible. So like if you go to a campus, surveying students available on the campus, it is one method. The next one is called as purposive. Purposive here means, suppose if you are going to do a study on performance, publications, and the life of research-based professors in universities. So you cannot interview all the professors or interview all the faculty who is teaching in a university or universities. Instead, you have to know the people who do research, the people who supervise research. So this is called as purposive sampling. Like if we want to do a study on experts, ICT experts in AI and robotics. So somebody may be an expert in IT, but may not be an expertise in robotics. So this is called as purposive sampling. The next one is snowball sampling. Sorry, this I explained many times more. Existing participants refer other participants with similar characteristics. This study can be done only when population is hidden. Don't think that, okay, let me go to somewhere, find one of my client or respondent, then let me find the second person from that one. Don't do that one. So there is a good reason why you have to fix into snowball. The next one is called as quota sampling. So if you have 1000 sample, you can give male how many, female how many. You can give quota. In that one, 18 to 25 how many, 26 to 35 how many, and others how many. So that depends upon the nature of your research, what you're doing. You can select the participants on predetermined quotas. So that is more important. So you can decide. Now, what is the goodness of non-probability sampling? The advantages of non-probability sampling or the strength, they are useful for exploratory and qualitative research, not for quantitative, please. So they are useful for exploratory and qualitative research. But the limitations, as you all know, this exactly cannot be the miniature of the population under study because you are using purpose, convenience, and some snowball and quota techniques. So how you will ensure every sample, every member of the population has to be a opportunity to become a part of the sample? No. So the limitation is lower generalizability. Because the results what you get, they are actual results. What is the challenge? The challenge is that they are not the real cross section of the population. So we cannot confidently apply to the entire population. This is one limitation when we use non-probability sampling in research. The next one is, I think, what is a simple random sampling? Here, everyone, I'm just coming a bit more closer and closer to random sampling. Here, every member has an equal and independent chance of being selected. Population first size, first thing, if you want to use simple random, population is homogeneous, then population frame is available. That is, full list of the population is available. Then only we can get everyone as an opportunity. So the stage one, how it works, list all the members, that is we call as sample frame, assign a number to each member, then you use random selection or lottery method. This you can see. If you have 100 people, 1 to 100, then you can pick up randomly. So that people become your sample. So like what you do in a university, in a class. If a class is having a population of 200 students, you can, if you are n, the small size n or sample size is equal to 100, you can randomly select 100 students from the class which is having 200 students. So the key takeaway on this board of simple random sampling, this also unbiased, isn't it? We are not purposefully. It is simple, unbiased, and it is easy to complete with the list what is available. So this is simple random sampling. Now, I just want to recall more in detail what is stratified sampling. So here what we do, we are dividing the population into subgroups. Why we do this? Because we need more precision, more representation. We have to ensure all key subgroups are included, and this gives more accuracy for our estimates. I wish to recall the study by William Odosh and how family relations helps a society's performance. So here you can divide the population under study or the samples to 3 categories, like people who are farmers, people who are in business, people who are in profession, isn't it? So we are dividing the population under study to subgroups. So let's take the case of the bank employees. We are doing a study in bank employees. We divide the employees in the bank into 3 levels: managers, officers, and trainees. So we get the first subgroup, which we call as the stratum. So when we do stratified sampling, the first thing what we have to do, we have to identify the important subgroups. How we are going to plan. The subgroup is called as strata. So that is your capability, your knowledge about the population. Because as a researcher, I tell you, if you don't know your population, that's not good for you. You cannot do a good research. That's why I say, when I walk in the slums, I literally walk. I move the place. And most of the times I prefer walking because I need to know what is actually happening, isn't it? So you should know the subgroups in the population. From that, you determine proportions. So how many stratas, how many people from each strata. From that, you can pick up randomly. So if you have 10 strata, even you can use uh, five stratas. That is left to you. Combine all samples from the selected strata. So the first section divide the population into subgroups. So in the subgroups, you should exactly know the population size. You can identify the proportion, the total out of the 100% sample, what proportion or population, what percentage it comes for. From that, you manage. If 20% of the population proportion is managed, so if you are collecting 100 sample, then 20 data should be from managers, 60 data from officers, 20 data from trainees. Hope you are getting me? How you are getting into the number of each strata and how you draw out the sample from each strata. You see, you are doing your population size is 800 when you're doing a study on the graduate trainee process in private sector banks of Uganda. And in that 800 people, you know that 120 are managers, 480 are officers, and 200 are trainees. So now your population is uppercase N. We divide the entire population into 3 stratas. And out of the total 800, 120 are managers. So that means around 20%. So it is good. Your sample size, 20 people should be from managers. So this is how we do random sampling. So stratified random sampling, the goodness with that, you can get the equal representation of each subgroup. And when we have more representation, equal representation, it is more reliable and it will lead to more accurate results. Hope this will help you to understand more on which is the best sampling technique for you. The next one is called as cluster sampling. So in cluster sampling, the population is divided into natural groups. Like it's not like a natural groups like cluster, because the population is geographically spread and we don't have a full list of the population. So why we use this? Because cost effective, time saving, all samplings are like that. Reduces travel and data collection things, and it is practical for large dispersed population. So if you are doing a study of the Ugandans working in Europe, Ugandans working in Asia, Ugandans working in the Middle East. So if you want to do such a study, they are geographically separated, isn't it? Or segregated. So I'll tell you how it works. First of all, if you are doing a study about the farmers or students or university students, sorry, you know, in Uganda, we have a northern region, eastern region, central, and western region, isn't it? So we can divide the population into clusters like districts of each region, then randomly select some clusters. In that, you select the universities or the school children. So that is how we normally do. So cluster based on districts. And in that one, out of we have around close to 145 plus. I think new 3 districts have come 148 districts. I think so. I'm not very clear of that one. So out of these 148, we want to study on a selected number of things. So randomly select some clusters, put them together. So like all districts of, we want to have 12 districts. So put 12 districts. From that, randomly select 3 districts. And from each district, select a number of samples. This is called as cluster sampling. Now, where we use, we'll discuss. Where we use this, So if you have questions, you can put in the message and we'll discuss later. Where we do this, we do this when it's for large geographically dispersed population. So, and it's very difficult for us to draw out a full sample frame. And if you can draw it, it will become very expensive. So at this case, we use cluster sampling. Now, the next one, purposive sampling. Now, here you need some kind of specific expertise and experience, because your purpose, you want to have a deep understanding of things. So you want to get sample from experts only. So that is why we use purposive sampling. Why use these kind of things? Because your data leads to deep drive understanding, and moreover, it saves time and resources, because we don't want unwanted data to come in between, and we are really explorative and qualitative in nature. So, like if I want to study on the graduate retention among the graduate trainees being recruited in the private sector banks, then I can do interviews with HR directors. I can do interviews with the topmost management team, senior people. So similarly, what we can do, depending upon the kind of data you need, depending upon the population of your study, you can do this purposive sampling. So here, purposive sampling, 100% is non-probabilistic, isn't it? You are, sorry, you are trying to find the specific features and characters. So when you want to have a purposive sampling, first of all, yours is a qualitative research, isn't it? That is first you have to ensure. So ensure the purpose of the study, identify what you are going to learn, identify what you are going to learn, identify the key information, select participants, and then collect data from the selected participants. So this is more important, because what we have to make sure, the participants, we are selecting them intentionally. We are selecting the participants intentionally. We don't take everybody as we like, because we have a purpose, what we are going to explore. So this is a kind of exploratory research, and you collect data. So if you take an example, if you are doing a research understanding the adoption of AI in higher education institutions, if you want to do that, then you can select the participants like HR directors, AI experts, and senior researchers, because you want to fetch data from them only, isn't it? So you should have a reason why you select them, because HR directors, they really understand the institutional policies. AI experts, they understand the AI tools and techniques. Senior researchers, they can contribute insights. So you as a researcher, you decide whether I have to use purposive sampling. There should be a reason why you are using this specific sampling method. So key takeaways from this board. Purposive sampling helps us to select most manageable relevant data. This is more important. So purposive sampling helps us to get the most manageable relevant data. Now, I'm not going to explain more on snowball sampling. This I've explained very well. Initially, you start with one participant. From there, you get referrals, and once you find everyone is on the board, your things end. Okay, so that is snowball sampling. This I told many times, but just to reinstall once again. If quantitative research, random, stratified. Qualitative, you can use purposive. Mixed methods, you can use a combination. Case study, good is purposive. If you are doing a data research, you can use algorithmic data sampling, that you can generate data by algorithms and you can take it. Yeah, using algorithms you can work. So key takeaway, depending upon your research type, you have to choose your research, you have to choose your method for sampling. So members, this is a simple example on our study on graduate trainees in Kampala banks. So we have a purpose of this study. We want to understand the leadership progression, those who are in the leadership pipeline, those who are selected as graduate trainees and how they are working. So the possible sampling, we stratified the banks by type. We can do commercial bank, microfinance bank, Islamic banks. Then the purposive, we can select HR managers and we can select trainees by random surveys. So if you look at the sampling framework, the banks can be in strata, individuals or leadership can be in purposive, and even you can have the graduate trainees who are in the banks can be in random. So this you have to understand in your research you can combine all these things, but there should be a good reason. Make sure if you are doing a qualitative research with hypothesis, the sampling techniques, it is good to have them probabilistic sampling. Probabilistic sampling is good if you are doing a qualitative research. Researches with hypothesis, structure equation modelings, it is good to have probabilistic sampling. But sometimes you can use non-probabilistic sampling and you can do your research. Now, the most common mistakes that happens with researchers. The first one, always we tend to use something is more familiar to us. Always we tend to use something is that is our way of life. That is human nature. We cannot blame anybody. So if you choose familiar methods, means the methods which you are more comfortable with instead of appropriate one. And why it leads? It leads to biased results. Many of the people say that simple random sampling, stratified random sampling. So it's not like that. You should have a reason. Then you copy from previous researchers, copy previous thesis. They have used that one. So my study is better. So I can use the same thing for same. There is no problem of using, but you should really know, does that research and your research are equated in the same way? Do they have the same research objectives? Are they aiming in the same track? So that you have to make sure. Then ignore population complex. This is more important. You have literally understand your population. Sitting at your office, okay, let me do this. No. You have to understand the subgroups. You have to understand the diversity. You have to understand the homogeneity, or you have to establish the heterogeneity. You have to see the variance. So based on that, you have to choose the right method. Now, people tend to use more on convenience over validity because you just think convenience is good because it is easy to reach. This whole waste of time because it not lead you good things. Then misuse of random. Yeah, this I want to tell you. See, if you are doing a qualitative research, it should be probabilistic random sampling. And for that, you should know the population frame. You have to arrange them in an order. Then you have to fix the kth one, isn't it? So people claim they do random, but do not follow the proper random procedures. Then it will not be random. And this ultimately lead to what? Rejection or limited acceptance. So these are the common mistakes I want to tell you all. Mistakes are human in nature, but you don't misuse. You don't overstress on convenience. Without knowing population, you don't do your study. It is your responsibility that you should know your population well. For convenience, you read some thesis, previous thesis, and you get that light coming like this. And do you think that is that the exact light for your research? May not be. So that is also important for you. And always prefer to choose what is familiar. Man. Fly an extra mile. Learn more. Like James told in the morning, he was reading. Read, try to understand what is more suitable, what is the most matching thing for you. Now, we are going to see the different sampling bias. What is a bias? The proper representation is not done with the target population. That is bias. If the proper representation is not done with the target population, then this is a sampling bias. And in that sampling bias, you can find any number of samples. I don't want to explain them now. We discussed this many times in our different researches. So this will lead to distorted results because proper representation is not there. So I'm just want to say 5 important bias that happens. One is selection bias. This is where you are not properly using probabilistic sampling technique. So the sample does not reflect the population, the real population. You know, as a researcher, your first aim, when you do sampling, your sample is a miniature of your population. Otherwise, what is the use of doing that? So this is one selection bias. Then is accessibility bias. What does it mean? Some areas you have more access. So like if you are studying on 3 departments, you have more access on marketing. So what happens? More data will be from marketing. Or you have more, sorry, you have more access for one region. Then what happens? That region will be overcrowded. That is accessibility bias. Now institutional bias also happens. It's the same, like you may have access more for 2 or 3 institutions, or it is close to you. So then digital bias, because you may do a survey with your Google Forms. So your survey goes to only people who are digitally connected, isn't it? So you are excluding people who are not digitally connected. So that is a digital bias. Then there is something called as a response bias, because that is why the way you try to capture data, especially in social science, it should be scientifically aligned, because you should not ask questions in such a way that the answers are hidden in the question and your respondent is forced to choose an answer that may not be the real opinion. So don't do like that. I was just mimicking a television interview. So like a television anchor, it's a comedy, okay. When we talk about questions and answers, the television anchor is asking a person who she is interviewing, does your family know that you are mad? If the person says no, the answer is you are mad. The person says yes, the answer is mad. Don't make such kind of questions. So, you know, these all makes, if the respondent says yes or no, what you want to achieve is gained. So don't do like that. So these kind of things are the different sampling biases happen: selection bias, accessibility bias, intuitional bias, digital bias, and response bias. Now, when it comes to ICT people, now in AI, we use with small data sets also, we can do a lot of predictions. So, like when I work with the agri brain, that is developing a brain for farming. So we use data sets from AI and we generate data using AI. We train the model, then replace the data with the actual data. So these kind of things can happen. So your AI can generate data for you, but that won't be the real data. From that data we can use to train the machine. Then we can, it gives real sensor like that to train the machine. Then we fetch the actual sensor data from IoT streams, multimodal data from different cameras. Then we do real-time analytics, and that data we use again to train the model. So, the research happens like that. But members, don't use only the AI data. You can literally generate the data using AI, but you don't use that data. This is all you can use for training the model, but don't use that data to say this is the real research outcome. That is very bad. So, in the new era of research, like when you do social science, get data from machines. We can get data from events. We can get data. Different time zones, timelines. We can get data. Different locations. We can get data, and even through digital interactions, we can collect the behavior of the people. Because if you look at the WhatsApp conversations, the actions, interactions, the emojis, what the people share through digital medias, the digital charts. Yes, it can give you some kind of data from which you can develop to identify their behaviors, predict behaviors, or what is the emotion of the person at that moment. So, two things I want to tell you. One thing, don't use data generated by AI methods as real data. To train the models, you can use real data. So, but AI help us to get real-time data. The methods will help us to get real-time data, real-time sensor data, and that data you can use for um, different purpose. So when it comes with the AI, it is different. It can generate data for you for missions, events, and locations and behaviors, and gives you good insights. The purpose, just to introduce you, we can use AI for all these works. So this is how we do different kinds of AI augmented research. For basically me, I'm working more on this one with agriculture, how we collect data sets, how we can do predictive sampling, then adaptive sampling, how can we work with real-time data, then AI-assisted response. If I'm doing a study among the university dropouts, I should have data first, the real data. Without real data, AI will not help you. People think that AI is the ultimate solution. To all my researchers, AI can help you to do analytics. Different AI tools are available, but you should have the real data with you. Otherwise, AI will hallucinate you. It can give all the data for you. Whatever data set you want the data set for 3,000 students, it can give you the data set. But is that the real data? Will it help you? So if you want to make a student dropout prediction system, AI can help you to make such a system. But for AI to make such a system, you should have the real-time data with you. That's more important. So, members, my researchers, data is the most important thing of your research. But to get the real data, to get the appropriate data that bridges you to the population is your sampling methods. So if you fail to choose the right sampling method, the appropriate sampling method, most of the researchers fails because of three things I told you before. Especially I said two things. The first thing, they forget their objectives. What is their mission, vision, what they want to do. The second thing, they do talk about the population, but really don't know about their population. That is the most biggest challenge. So try to get out of your couch, get out of your room, move, move to the areas, the gray areas, understand about your population, what is the real life of your population. If you're working with machines, if you're working with man, if you're working with material, everywhere you should have a real exposure to your population. If you sit at your home, you can make a good research, but I don't feel it's as good one. So that is one call I want to tell you all. We can use AI, digital-based research in smart agriculture, in healthcare. These kind of wearables what we wear. These wearables, it fetch data. You can see. Even you can see a change in focus because it is using AI systems to autofocus what is coming in front of it. Then social media analytics, smart cities, cybersecurity research, and for finance and business. So AI is good, but without data, AI is not good. So that's what I want to tell you here now. Now, members, I'm getting into the final slides. The golden rules for selecting samples. The first rule is, what is my research objective? You should have a clear idea. What is my population structure? Does it has subgroups that homogeneous or heterogeneous? Is in my study, do I need generalization? Are all my respondents accessible? What are the resource limitations for me? Time, money, or the major challenges will be for almost researchers have seen time is the major challenge because they keep all these things at the end of the day. Like they want to complete the research in a time period within the university, but escalation. Then running rush, such becomes bad. The next, what level of accuracy you need? Is that 95%, 99%? You know that very well. So if you have the right questions, research questions, lead you to right sampling, will get you reliable data. And this lead to stronger conclusions and your research 100% will have an impact. So the key takeaway, what I want to tell you, good sampling starts with right inner questions to you. You ask yourself, what I'm searching for? What is my research question? Now you may think that, oh, Dr. Paul, you are asking us to go back where we started the first day. Yes, there is no harm in doing that one. This will help you to install, reinstate, improvise your thought process day by day. Research is a regular process, and every day should be a new day. So it should help you to have reach to better sampling, get strong data, and this will lead to a strong, trustworthy results which are of great impact. And the final research truth. This is the final thing I want to tell you. Sampling is not about choosing people, man. Don't mark it as I need 300 samples. I need 300 respondents. I need 180. I need 400. Don't hunt for that number. Make sure your sample is the miniature of your population. You're going to see it is the lens through which you're going to see and generalize your entire population under study. So first of all, as a researcher, either you're doing a micro, meso, or macro, the full PhD research, you should be able to understand your research question on one side, your population on the other side. Sorry. You must understand your population. It is a must. So, I say a well-chosen sample brings the real world in front of you. And that makes your research meaningful. The goal should be not to collect data. The researchers finally, my God, I want to have this much data. Let's put it in SPS or in machine and sort out. Do it with integrity, man. Let's try to bring the real life to your data sheets. So, great research begins with great sampling, and that leads to meaningful things. The last slide. what is the best sampling and what is not. Don't make it so complex. Yeah? Simple. It should collect your research problem. No need that it is extremely statistical. It should not be extremely popular. What is good fit for you? What fits well for you? What fits for your research problem? What fixes for your research based on the reality of your population, and what methodological and practical feasibility and validity you are looking for. That is most important sampling technique for you. You don't want to use X has used this technique, so I have to use it. Y has used this technique, so I have to use it. Z has used this technique, I have to use it. Man, it's different for each one of you. So the final reflection to all my scholars who are hearing me from all over the world. If your sample does not reflect reality, can you reflect the truth? Now, I can be a Bible preacher or I can be a religious preacher. When I call everyone to love your neighbors, support them, and I am a hell-like person who never practiced at my place, does I reflect the real thing? So similarly, for you people, make sure your research is your reflection. So choose your correct sampling technique. Not necessary that you have to use this one. I'll use this one because my professor explained me that one in more detail. No, don't do that. So I have some activity for you. Since it's an online session, you can do by yourself. At least you do a mini exercise for 10 minutes. We are going to do it now. Okay. State your research topic on a piece of paper. Identify your population. Choose one sampling method and you justify. So this is the exercise I'm going to give you now. I'll be stop recording and I'll continue with the same link, and after 10 minutes. The time now is, it is 27 past 12 p.m. So 30 minutes to half past. So after 10 minutes, like 47 minutes. Okay, like 23 minutes to 1 p.m. Like I will get back to you. So kindly do this exercise. This slide will remain here. So you do this exercise, state your research topic, identify your population, choose one sampling method. So with that, we will conclude the session. So I'm not ending up the session. I'm just keeping away for 10 minutes. Once the exercise is done, get back to me. Thank you. Members, how far we? Are you able to do what I am said?